In lesson 3.2, we're going to look at different ways to prove that triangles are congruent. So before we get into that, we want to go over the included angles and included sides again, just to make sure that we have that down. So what are the included angles and what are they included between? So you've got angle A is included. Well, can't even read that. All right, that's a little bit better. Is included by side AB and AC. All right, so does that make sense again? We've got angle A right here. It's in between basically which two sides, AB and AC. So what are the other included angles that we have? Angle B is included by, I'm just going to do that to show the same thing. B is in between side AB and BC. So here's angle B. It's included between these two sides. And then the last one is angle C is included by, or is in between sides BC and AC. Now if you wrote some of those, remember the segments, if you write them in a different order, that's okay. It still is the same side of the same triangle. All right, so what are our included sides? So side AC is included between which two angles? So find side AC, and it's between angle A and angle C. Does that make sense what I'm doing? I'm kind of not writing in the is included between piece. Side BC is included between angle B and angle C, and then side AB is included between angle A and angle B. So we're going to use that information going forward. All right, well, we've got four basic ways that we can prove that triangles are congruent, and we use these little abbreviations like SSS. So SSS stands for side, side, side. It's very creative. What that means is that if you have three congruent sides in a triangle, that means that the triangles are congruent. So for example, if you look at all of our markings up here, we can see that side AC is congruent to EF. So there's one side that's congruent. We also can see that side AB is congruent to side DE. So all that I'm doing is I'm matching up these dashes, these corresponding marks over here. So now we have two sides that are congruent, and then, or two pairs of sides. And then our last one, we have BC is congruent to DF. And then, yes, okay. So there's our third side that's congruent. So there's your side, side, side. What we can conclude then is triangle ABC is congruent to triangle EDF. Do you see how I was careful with how I wrote that? I had to make sure that all my angles matched up with each other right there, just so the triangles are in order. Now, what's the reason that these two triangles are congruent? The reason is side, side, side. That's all you have to say. All right, so here's our next pair of triangles, and we can show that these triangles are congruent by SAS. So SAS stands for side, angle, side. And I want to point out that this angle, do you see how it's in between the two sides? That means that it has to be an included angle. That's very important. All right, so if we look at, just real quick, do you see how we have angle C over here? And we've got these congruency marks for AB and BC. Is angle C an included angle between our two sides that are congruent over here? No, it's not in between them, so we wouldn't use angle C to help us prove these triangles are congruent. All right, so let's list out our congruencies. We've got side AB is congruent to side FD. So there's our side. Now we need an angle that's congruent, and we have angle B is congruent to angle D. We've got those 90-degree boxes right there. That means that they have the same measure. So there's our angle, and then side BC is congruent to side DE. So there's your side, angle, side. So that allows us to make the concluding statement that triangle ABC is congruent, what was that? Is congruent to triangle FDE. And what's the reason? Side, angle, side. All right, here's our third way to show that triangles are congruent, ASA, but you can guess what it stands for. Angle, side, angle. Now, do you see how this side is in between the two angles? That means that it has to be an included side. So it has to be the side in between the two angles that are congruent. So let's look at our triangles and list off our congruencies. I can see that angle A is congruent to angle D. The included side, AB, is congruent to side DE. And then we have angle B is congruent to angle E. So there's our side, angle, side. So that's enough to say that the triangles are congruent. So triangle ABC is congruent to triangle DEF. You do want to make sure that you have that in the correct order. So I always kind of double check as I'm writing out the second triangle. And what's the reason? Why are we able to just say the triangles are congruent with only 3 pieces of information? Side, angle, whoop, not that one, just kidding. This is not side, angle, side. This one is angle, side, angle. All right, this is our last one. We have AAS, stands for angle, angle, side. And this one does not have an included angular side. You know, an angle would be included between two sides, and this is saying an angle and a side. So we're going to have basically 2 angles, and then this last side is not the included side between the two. All right, so let's look at our congruencies. List them off. We've got angle A is congruent to angle D, so I'm just matching up those marks. We also have angle C is congruent to angle F. So there's our angle, angle, and then which sides are congruent? We've got BC is congruent to EF. So here's your angle, angle, side. That, if you have an angle, angle, side combination, you can say that your triangles are congruent. So we'll say triangle ABC is congruent to triangle DEF. And what's the reason? Angle, angle, side. So you've got 4 of those that you can use as reasons to show that triangles are congruent. So just to recap, you have side, 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 angle, side, angle, side, angle, and angle, angle, side. All right, it's really tempting And there's some math behind why you can't do this, but if you wanted to if you had two sides and a non-included angle, that is not sufficient information to show that two triangles are congruent. And the best way I can tell you to kind of remember that you can't do side-side angle is if you look at that, it spells a bad word backwards. So don't use the one that does that. All right. All right, so there's your intro video.